Let us start with the non-empty set. We start with any function from x cross x to real numbers. Any function from x cross x to R satisfying these properties. What properties? Distance between x comma y, which is non-negative for every x comma y belongs to x. Distance between x and y, which is 0, if and only if x equals to y. And distance between x and y equals to distance between y and x. This is true for every x and y, which belongs to x. And triangle inequality. That means distance between x and y less than or equals to distance between x and z plus distance between z and y. This is true for any three elements you take. Any function from x cross x to R. That means you take any order pair from x comma y, x cross x. D of x comma y is nothing but a real number. You know that function. You know that function. What do you mean by function? Any element of x cross x has a unique image in R. You know that in basic real analysis. So any function from x cross x to R is nothing but a metric. What is this? It is nothing but a metric on x if and only if it satisfies these four properties. First property is distance between any 2 points, which must be non-negative for any 2 points, and distance between any 2 points is 0 if and only if the points must be coincident. And distance satisfies symmetry property. That means what? If you interchange the elements in x, the distance doesn't change, and the distance satisfies the triangle inequality. Any function satisfying these four properties, this d is nothing but a metric on x. What is d? D is nothing but a function. D is nothing but a function. Function satisfying four properties, nothing but a metric on x. Whenever d is a metric on x, x comma d is a metric space. Is it clear the definition? Any function from x cross x to R is nothing satisfying these four properties is nothing but a metric. What is meant by metric? Metric is nothing but a function satisfying these four properties. Any function from x cross x to R satisfying these four properties is nothing but a metric on x. Here x comma d is nothing but a metric space. Whenever d is a metric on x, x comma d is a metric space. Is it clear the definition?
Please put in chat box. Yeah, clear, sir. Clear, sir.
Yeah. So let us start with simplest example. Suppose you take x is equals to R. My function x cross x to R. What is my function here? When you take x comma y is an order pair, what is my function? My function is, for example, x minus y. That means distance between x comma y is nothing but x minus y. Whenever x comma y is real numbers, my set is real numbers. Right? Question is that, is it a metric? Is it a metric? Is the function is metric?
No, sir.
No. Why? Because what is meant by metric? Any function satisfying these four properties. That means distance must be non-negative. It cannot be never be negative. It cannot be negative. Distance must be non-negative. Suppose you take x is equals to 0, which is a real number. Suppose you take x is equals to 0, which is a real number, right? X is equals to 0 and y equals to 2. So what is my distance? Distance between 0, 2. That means 0 minus 2. That means minus 2, which is negative. So which is contradiction to the first property. So which fails to the first property. Therefore, it is not a metric. Is it clear?
Yes.
Is
Yes,
it clear?
Yes, sir.
Suppose, so what is the problem arises here in this question? Means that means whenever you define a function here, d is a negative function. You are getting a d is a negative function. But what I need is actually here is that d must be non-negative from the first property. Understand? From the first property, d must be non-negative. So how to rectify this problem? So you are getting your negative. So how to rectify the problem? When you take the modulus. When you take the modulus. Yeah, good. When you take the modulus, where whenever x comma y belongs to R, it is a non-negative function because modulus is always v-shaped function which is above x-axis, always non-negative, So first property, when you take two elements in R, is the distance non-negative? Yes, the answer is because mod of x minus y is always non-negative. But mod of x minus y is nothing but what? Distance between x comma y, which is non-negative. Therefore, distance between any two elements, which is non-negative for any two elements in R. So first condition is true. So non-negative property is true. Understand? Non-negative property. This is what non-negative property. Right? So distance between any two elements which is non-negative. What is my second property? You take any distance which is 0. I want to show that this x equals to y. But what is mean by distance here? Mod of x minus y. So mod of x minus y equals to 0. So you know that mod x is equals to 0. Mod x is equals to 0 if and only if only x is equals to 0. So therefore, x minus y equals to 0. X minus y equals to 0 means x equals to y. So therefore, distance between x and y equals to 0 if and only if x equals to y. So that means it satisfies the second property. So what is the third property? You need to inquire the symmetric property. That means if you change the variables, the distance doesn't change. That means you start with two elements. You start with any two elements. You consider the distance. What is the distance here? Mod of x minus y. You know, basic. You take the minus one common. What is this actually? Y minus x. That is nothing but what actually? Mod of minus x is equals to, you know that mod x is equals to mod minus x. Both are same. Mod x is equals to mod minus x. Therefore, this is nothing but mod of y minus x. This is nothing but y comma x. Therefore, distance between any two x comma y equals to distance between y comma x. Therefore, D satisfies symmetric property. So therefore, what is the last property? Triangle inequality. What is my last property? Triangle inequality. So what is the triangle inequality? So you start with two elements. To prove triangle inequality, how many elements I need? I need three elements. When you take three elements, when you consider three elements, sum of two sides always bigger than equals to third side. This is two sides. So sum of two sides always bigger than equals to third side. That means you start with two elements. You start with three elements. Sorry. So consider distance between x and y. That is nothing but what? Mod of x minus y. So this can be rewritten as adding and subtracting z. So you know that by triangle inequality in basic real analysis, mod of a plus b always less than or equals to mod a plus mod b. This is true for any two elements which are in R. Right? So therefore, this is my a, this is my b. So by triangle inequality, mod of x minus z plus mod of z minus y, this is nothing but d of x minus z plus this is nothing but d of z comma y. Therefore, d of x comma y is less than or equals to d of x comma y less than or equals to d of x comma z plus d of z comma y. So therefore, D satisfies triangle inequality. Therefore, D satisfies all condition. Therefore, D is a metric on R. Is it clear? Is it clear?
Voice is clear? Okay.
Okay, sir. Okay, sir.
Yes, sir.
Yeah,
Yes, sir.
yeah. This is
Please
clear.
put in chat box.
Okay, sir.
Is it clear the example? Because this is the first example. So when you have any doubts, just ask me.
Sir, D is a function అన్నారు కదా sir.
Yeah.
Oh,
So sometimes it is called as D is a distance అనొచ్చా sir.
distance function, sir.
Distance function. Sometimes it is called as a distance function or else metric. Or else metric.
Oh, okay, sir.
Because this is the first example, so that you need to understand the problem. Okay. Is it clear, all of you? Okay. So D is a metric. So this metric is nothing but actually, this metric is nothing but means d of x comma y is equals to mod of x minus y on R. This metric is nothing but actually usual metric or standard metric or Euclidean metric. So that means whenever you are not given any metric on R, so what is the metric you are taken? You need to take the mod of x minus y. D of x comma y is equals to mod of x minus y. This is what usual distance or usual metric or standard metric or equivalent metric. So this is nothing but usual metric. Suppose third example, if I'm taking this x minus 2y, whenever x comma y is the real numbers, is it a metric? Is it a metric?
Yes, sir.
Yeah, put it in chart box. Is it a metric?
No, sir.
So the best, first you need to guess the problem, first of all, where it fails. First of all, there is no problem with non-negative because actually modulus is there. Understand? Modulus is there. So whenever modulus is there is no problem with non-negative, right? The first property is automatically satisfied, right? The problem with second one. So what is second one? So d of x comma y is 0 if and only if x equals to y. This is a very important property. So here actually suppose, so how to guess the problems? See, d of x comma y is 0. That means mod of x minus 2y equals 0. So mod of x is 0 means x minus 2y equals to 0. That means x equals to 2y. That means what? So this is nothing but actually any line passing through origin, right? So suppose you take any element. Suppose you take element. For example, what you take actually 2 comma 1, right? So 2 comma 1 satisfy this equation, right? 2 comma 1 satisfies this equation, right? 2 into 1. That means what? Satisfy this equation. Therefore, distance between 2 comma 1 is nothing but what? 1, 2 minus, that means 0. That means mod 0 is nothing but 0. So distance between 2 comma 1 is 0, but 2 not equals to 1, right? Distance between 2 comma 1 is 0, but 2 not equals to 1. So therefore, it is not a metric. Is it clear? So guess the problem, first of all, guess the problem. So this is a guess. So that means what? X minus 2y equals to 0, x is equals to 2y. X cannot be equals to y because actually there are so many points, uncountable many points for which distance, whose distance is 0, but the coordinates are different. The coordinates are different. The coordinates 2 not equals to y, 1. Because this is a line passing through origin. There are so many points which fails to satisfy this property. Is it clear? Because I need at least 1 point fails the property. I need at least 1 point. I need at least 1 point which fails this property. Is it clear? You can take for example, you can take actually what you take actually. Suppose you can take x is equals to 2, x is equals to 4, y equals to 2. Nothing wrong, right? Nothing wrong. X equals to 4, y equals to 2. So satisfy this equation. Therefore, distance between 4 comma 2 is nothing but what? Mod of 4 minus 2 into 2, that means what? 0. So distance is 0, but the points are different. 4 not equals to 2. Is it clear the idea? Put it in chart box. Put it in chart box. Yeah. Okay. Suppose I can slightly change. Suppose I'm going to take another example. Distance between x comma y is equals to, suppose, 2x minus 1. Is it a metric? Is it a metric?
No.
No. The same strategy
sir.
works, right? The same strategy works, right? There are so many points. This is also so this is also line passing through origin. Y equals to 2x. Y So this is also same argument which gives the solution. If you take x is equals to 1, y equals to 2, that means what? So distance between 1 comma 2 is nothing but what? 2 minus 2, that means 0. Distance is 0, distance between 1 2 is 0, but 1 not equals to 2. Therefore fails to satisfy the second property. Therefore it is not a metric. Right? Is it clear? Is it clear?
Yes, sir. Go ahead, sir.
Okay. Next example. Suppose you take distance between x comma y is equals to, suppose, sine x minus sine y. Whenever x comma y are the real numbers. Question is that, is it a metric? Put it in chat box.
Monica is saying yes. Oh, okay.
Okay. So first you need to guess the problem. What is the first argument? You need, when you want to say that D is a metric, first you need to know that first property must satisfy the first property. So there is no problem with first property because modulus is there, mod is always non-negative. So first property, there is no problem. So what is the problem actually you're facing? You need to know the second property. So distance between x and y is 0. That means mod of sin x minus sin y is 0. That means what? That means what? Mod is 0. When do you say that mod 0? If and only this sin x minus sin y equals to 0. That means sin x equals to sin y. That means you know that actually, can you give it two elements? Can you give x and y in such a way that sin x is equals to sin y? Yes, the answer is yes. Can you give me x and y which are real numbers in such a way that whose sign images are same but x and y are different? Can you give me x and y which are real numbers? In fact, can you give me distinct elements whose images are same under the sign function? Sin x is equals to sin y. Can you give me two real numbers which are distinct whose images under the sign functions are same? The answer
Yeah.
is because sin
0
is a
and
periodic
180
function.
degrees.
Sin is a periodic function. Sin is a periodic function. We can give so many values. Suppose x is equals to 0, x is equals to pi, x is equals to 2 pi, x is equals to 4 pi. I need at least 2 points, right? I need at least 2 points. X is equals to 0, x is equals to pi is enough. Understand? Sin 0. If you take x is equals to 0, y equals to pi. So what happened? Sin 0, 0, sin pi is 0. Therefore, distance is equals to 0. Understand? Distance between pi comma 0 is nothing but what? Sin pi minus sin 0. That means sin pi is 0. Sin 0, 0. That means 0. Therefore, distance between pi comma 0 is 0. But pi not equals to 0. Is it clear? First, you need to guess the idea. That is important in analysis. Guess the idea and proceed. Guess the idea and proceed. Guess the idea and proceed. In general, sin x is equals to sin y. That need not imply that x is equals to y because sin is not one function, right? Sin is a periodic function with period 2 pi, right? Is it clear or not? Sin x equals to sin y. That doesn't mean that x equals to y. Yes or no? Right? So this one is not a function, right? This metric. This is not a metric. Suppose, see what is the problem here? Actually, the problem you're facing is that actually domain is R. When you take the domain is R, you're getting a problem, right? Because it is not a one function. It is a periodic function. So therefore, once you restrict the domain, you take actually what? Pi by 2, 0 to pi by 2. Same problem.